Hi everyone, can we find all the four solutions of the equation 81 is equal to 16x to the power 4? Okay, if you look at it, the power of the variable x is 4, so it is a polynomial of degree 4. And so this equation must have four solutions. Alright, so let's look at it. 81 is equal to 16x to the power 4. Okay, 81 is equal to 16x to the power 4. Now, we do not make the error to say divide both sides by 16 to obtain 81 all over 16 is equal to x to the power 4. From whence we now take 81 as 3 to the power 4, 16 as 2 to the power 4, x to the power 4. Now we take foot root of both sides. If we do that, we're going to obtain 3 all over 2 as x. This will give us just one of the solutions, but we are expected to have four solutions. So how do we get all four solutions? We have 81 equals 16x to the power 4. So what we need to do is to form the quartic equation by bringing everything to one side and having 0 on the other side. So let's take 81 from the left hand side to the right hand side so that we obtain 0 on the left hand is equal to 16x to the power 4 minus 81. Or we can rewrite it as 16x to the power 4 minus 81 is equal to 0. So that we have 0 on the right hand side. Okay. Now, at this point, we can see that it will be nice to make x to the power 4 to be with coefficient 1. So we divide all through by 16. We divide here by 16, divide here by 16, divide here by 16. You see 16 cancels. And so we obtain x to the power 4 minus 81 all over 16 is equal to 0. Remember, 0 divided by anything is 0. Okay. X to the power 4, 81. We know 81 to be 327 divided by 3, 9, divided by 3, 3, divided by 3, 1. 1, 2, 3, 4. 81 is 3 to the power 4. Also 16, we will keep dividing by 2, 8 divided by 2, 4 divided by 2, 2 divided by 2, 1. 1, 2, 3, 4. 16 is 2 to the power 4. So we have written now 81 and 16 in index form with power 4. So 81 is 3 to the power 4, 16 is 2 to the power 4. Since the powers are the same, we can just write this as x to the power 4 minus 3 all over 2 raised to the power 4 is equal to 0. So we have difference of expressions in the power 4. X to the power 4 minus 3 all over 2 to the power 4. But we don't have an identity of difference of power 4. We know of identity of difference of power 2. So we know that 4 is 2 to the power 2. So we can modify this equation to fit an expression having difference of 2 squares. So we can write this as x to the power 2 raised to the power 2 minus 3 all over 2 to the power 2 raised to the power 2 is equal to 0. Okay, so that at the end of the day we have an expression squared minus an expression squared, giving us a difference of 2 squares. Remember, a to the power m raised to the power n is a to the power mn. We just multiply the power. So you multiply this power, you get back 4. You multiply this power, you get back 4. So we have respected the law of powers in indices. Alright. Now, we have obtained the difference of 2 squares. So we are going to use the identity of difference of squares. A squared minus b squared is identically the same as a minus b into a plus b. This is the identity that we are going to use. Okay, this is the identity that we are going to use. Now let's go ahead and transform this our expression using the identities of difference of squares. So we are saying that x squared minus 3 all over 2 squared will be identically equal to, when we use the difference of squares identities, let's write it well. We have x squared minus 3 all over 2 squared will be identically equal to x squared minus 3 all over 2 squared into x squared plus 3 all over 2 squared, when we use the difference of squares identities. Okay, so let's write this out here. We have x squared minus 3 all over 2 squared. This again is a difference of squares of its own. So if we use the identity of difference of squares, this is x squared minus 3 all over 2 squared will be x minus 3 all over 2 into x plus 3 all over 2, using the difference of squares identities again. So this expression up here can be written in full as, in the place of this, we're going to write this to have x minus 3 all over 2 x plus 3 all over 2, all of that into x squared plus 3 squared all over 2 squared. Alright, remember everything was equated to 0, equals 0. Alright, this is the equation that we have to solve. We obtain this expression multiplied to this expression multiplied to this expression, giving us 0. If that is true, then either x minus 3 all over 2 is 0. If that is true, it means x is equal to 3 all over 2. That is our first solution. Or this other one, x plus 3 all over 2 is equal to 0. If that is true, it means x is equal to negative 3 all over 2. This is our second solution. Or this third expression also will express it to 0. X squared plus 3 squared all over 2 squared is equal to 0 to solve. Okay, so we have had the first two solutions. Remember, we are expected to have 4 solutions. These are the first two. This is a quadratic equation which will help us get the remaining 2 solutions. Now this is the same as x squared plus 3 squared is 9, 2 squared is 4, is equal to 0. This is the quadratic equation that we have to solve. So let's collect our information. A is the coefficient of the x squared term. B is the coefficient of the x term. There is no x term here, so B is 0. And our C is the constant, which is 9 all over 4. Alright, so we use the quadratic formula, which says x is equal to minus b plus minus the root of b squared minus 4ac, all of that divided by 2a. That is a quadratic equation that we have to use. Now let's put everything in our formula and see what we get. So we're going to have x is equal to 0 plus minus the root of 0 minus 4 into a into c, 9 all over 4. All of that divided by 2a. So that gives us plus minus, that's x equals plus minus the root of negative 4 into 9 all over 4 all over 2. Alright, that gives us plus minus the root of 4 cancels there, negative 9 all over 2. This is the root of negative 9. And root of negative numbers do not exist in the real number line. So we expect to have complex roots there. Alright, so it just simply gives us plus minus root of negative 9 is 3i. Okay, or we'll go ahead and show how we got the I. Plus minus the square root of negative 1 multiplied to 9 all over 2. This is equal to plus minus the square root of -1 multiplied to the square root of 9 all over 2. So plus minus, remember the square root of -1 is I and the square root of 9 is 3. So you're just going to have plus minus 3I all over 2. Okay? This gives us plus minus 3I all over 2. Therefore, our solution, our remaining two solutions will be x equals positive 3I all over 2, and the remaining solution negative 3I all over 2. So this gives us all the four solutions: x equals 3 all over 2, x equals negative 3 all over 2, x equals 3I all over 2, x equals negative 3I all over 2.